Hello everyone, I am Rahul. I am from India. I am a topic for breakthrough challenges Newtonian mechanics and its limitations. Mechanics is a branch of physics that deals with the actions of forces on the material objects, and Newtonian mechanics is a branch of mechanics that deals with the relationship between the force and corresponding acceleration the force causes. Now, we need to know the reference frame concept. Reference frame consists of three mutually perpendicular coordinate axes that can locate the position of the particle and which can define the change in the positions, and velocity is the time rate of change of position vector. Position vector is the vector starting from origin to the location of the representative point of the particle. This is the velocity, which is the time rate of change of position with respect to time. Acceleration is the time rate of change of velocity. Now, inertia of a particle is its characteristic property that resists to any change in the state of uniform motion of the particle. Consider two rocks placed on the ground. Now, the inertia, we say that the inertia of the smaller rock is less than the inertia of the bigger rock, because to move the smaller rock we need to apply less force compared to the force which is required to move the rock of bigger size. This is the inertia, and the quantity inertial mass is introduced to measure inertia of the particles. Linear momentum is a quantity which is the amount of motion contained by the moving body. Linear momentum is defined as the product of mass and the velocity of the particle. Force is the influence caused by a particle on the another particle. Now, the interesting topic we are going to discuss now is Newton's second law of motion. Newton's second law of motion states that the net force, which is the sum of all the forces acting on the particle, is equal to the time rate of change of momentum. Here the mass is constant. For constant mass systems, mass is constant, and dv by dt is the acceleration, instantaneous acceleration of the particle. This is the statement which we have concluded from the Newton's second law of motion. Net force is equal to mass times acceleration. Newton's third law of motion. We are going to discuss now Newton's third law of motion. Before that, here I stated a statement: the state of rest and of uniform motion are equivalent in dynamics. But if the acceleration is zero, that means velocity is same. In the state of rest and in the state of motion, velocity is same. Here the velocity is zero. Here it is constant. But all over the velocity is constant. So the acceleration is zero. Then mass into zero gives the force as zero. So if the force is zero, acceleration will be zero. This is the Newton's first law of motion, and that can be said simply by using Newton's second law of motion. Now the Newton's third law of motion states, and here is another statement which I have written: two particles influence each other if the two particles have same character. It may be mass, electric charge, and anything. Here there are two particles A and B. This is the force acting on particle A and applied by particle B. This is the force acting on particle B which is applied by particle A. These forces, two particles influence each other, and these forces are created because of the characters of the two particles. The force acting on A which is applied by B plus the force acting on B which is applied by A. This is the net internal forces on the system of two particles A and B. These two forces sum will be zero, and these two forces are equal in magnitude and opposite in direction. This is the statement of Newton's third law of motion. And now we are going to discuss the types of reference frame. Reference frames are of two types. First one is inertial reference frame, and second one is non-inertial reference frame. And from inertial reference frame we can define the quantity of inertia, and from non-inertial reference frame we cannot define the property of inertia, because consider a particle of mass m which is accelerating with respect to inertial reference frame. If there is an acceleration in the reference frame itself, so here there is an acceleration, right? We have learned that F is equal to ma, the same I have written here. Now with respect to non-inertial reference frame, the force acting on the particle with respect to inertial reference frame plus the force which we call pseudo force. This is another kind of force, an imaginary force which we should consider when the when we are seeing from the non-inertial reference frame. This is the force acting on the particle with respect to non-inertial reference frame, which equals force on the particle with respect to inertial reference frame minus mass into acceleration of the non-inertial frame with respect to inertial reference frame, and the pseudo force is minus mass into acceleration of non-inertial reference frame with respect to inertial reference frame. Here we can again write that as force of the particle with respect to non-inertial reference frame is equal to mass into acceleration of particle with respect to inertial reference frame minus acceleration of the non-inertial reference frame with respect to inertial reference frame. If these two accelerations are same, then the force acting on the particle with respect to non-inertial reference frame will be 0. Here consider an example. Here there is a car accelerating with respect to ground reference frame. This is G, small g is ground reference frame. Ground reference frame is assumed to be inertial reference frame. Here is a man standing, stationary man. Here is a tree which is also stationary with respect to ground reference frame. Here we can write force acting on the tree with respect to ground reference frame is equal to mass of tree into acceleration of the tree, which is 0 with respect to inertial reference frame or ground reference frame. The force acting on the tree with respect to car and accelerating reference frame is equal to mass of tree into the acceleration of acceleration of tree, which we consider according to ground reference frame 0 minus the acceleration of car with respect to ground reference frame. And here we see that the force acting on the particle with respect to non-inertial reference frame is equal to force of the particle, which is pseudo. From the non-inertial reference frame, we need to consider another force which is pseudo, such that there is a modification in the Newton's laws of motion. If the acceleration of the particle with respect to inertial reference frame is 0, example is a tree, then the pseudo force is equal to the force acting on the particle with respect to non-inertial reference frame. And there is an example for Newton's third law of motion. This is an interesting example. Consider a table on which a block is placed. Now if we enlarge this small image to this large image, these are the atoms of the block and these are the atoms of the table. These two atoms repel each other because of the electronic repulsions. Now due to the electronic repulsions, the block atoms repel the table atoms with a force which is gravitational force of the block, and the table atoms repel the atoms of the block, and the resultant of all the forces, upward forces, we call as normal force, and the resultant of all the downward forces we call as gravitational force. And these two forces are equal in magnitude and opposite in direction. This is one of the example of Newton's third law of motion. And I hope you all have enjoyed my video, and thank you.